In the given circuit, I will use Thevenin's theorem to find I, which is current through this branch, 12 ohms and 30 volt say voltage source. So since I will use Thevenin's theorem, what I will do, I will disconnect the 12 ohms, because that is where the current through which the current goes through, or desired current I. So that's there, and I will leave the 30 volts there. I won't remove it. This one also stays there, which is 50 volts, and then I have the 40 ohms here resistance. So that's there. This one is the open circuit here, because I am trying to find the current through this branch. So I am attempting finding Thevenin's circuit for this resistance, this particular resistance, 12 ohms. So I have 10 ohms there, and since I have an open circuit, I will to find V Thevenin, I will find the open circuit voltage here, that is this one, which is V OC, which is V Thevenin. So what I can see, there is now, this one is 30 volts, and there will be no current flowing through this branch because this is an open circuit. At this moment current will be 0, so the current will be only due to the 50 voltage source, and this, the flowing path will be this one. So basically the resistance that this one will experience, the 50 volt source, is 10 ohms and 40 ohms in series. So I will be, if I find an I, which is, let's call I1 maybe, the current through the 40 ohms resistance will be 50 volts divided by 10 plus 40, which is 50, so that will be 1 amps. So since the current will be 1 amps through the 40 ohms resistance, the voltage drop across this one will be 40 volts, because 40 ohms times 1 is 40 volts, and this drop is 30 volts here. So basically V 40, let's call it, is equal to V Thevenin plus 30 volts. That's what it has to be, because this is the same branch. This one plus this one will be 40. So V Thevenin will become, V40 is also 40 minus 30, that is 10 volts. By V40 I just tried to write 40 ohms resistance, but since the current is 1, this one is also 40 volts, but yeah, so that's that's equals to 10 volts. So V Thevenin is 10 volts. So let's draw it here. 10, that's V Thevenin, and we need to find also the Thevenin's resistance. In order to do that, we will have to short out the voltage sources. Since these are voltage sources, in order to make them inactive, I will have to short them out. So this one will become 10 ohms here, and this one will be there, this one will be shorted out, and this one will be 40 ohms here, and R Thevenin seen from here, as seen from here, this terminal basically. So that will be, we can see here that the 10 ohms and 40 ohms, these two are coming in parallel when we see the, try to find the resistance as seen from here, this terminal. So 10 times 40 divided by 10 plus 40, which is 50, so that will be 8 ohms. So 8 ohms is the resistance there. So our Thevenin's resistance is 8 ohms there, and the resistance through which we wanted to find current, the current, that is the current I, the resistance is 12. So basically I am just connecting the Thevenin's resistance to that 12 ohms. So that's there now, and this one is R Thevenin, which is 8 ohms, R Thevenin RTH, and V Thevenin is 10 volts. So our current I will become, I is equal to V Thevenin divided by R Thevenin plus 12. So that one is, I is equal to 10 divided by 12 plus 8, which is 20. So I is equal to 0.5 amperes. So that's the result here using Thevenin's theorem.